Good morning, my name is Monique Ward and I'll be taking you through Unit Standard 252036. The title of this unit standard is Apply Mathematical Analysis to Economic and Financial Information. The specific outcomes of this unit standard are: use mathematical techniques to collect and organize data, apply mathematical techniques to calculate and represent financial and economic data, and apply mathematical analysis to indicate economic relationships. There are four various methods to collecting data: direct observation, interviews, surveys, and experiments or testing. An example of direct observation would be standing at the traffic lights and noting the variety of vehicles that pass through those lights at a given time. An example of interviews are literally asking questions of individuals and then noting their answers. An example of a survey would be what my husband did the other day with his doctorate. He had to send out 350 surveys and those individuals had to answer it online, and then he analyzed their responses. When analyzing data, there are two kinds of variables, namely an independent variable and a dependent variable. When my husband was researching his doctorate on entrepreneurial success, that would be seen as the dependent variable. He then noted that he had 10 independent variables that would affect his dependent variable, namely entrepreneurial success. Those independent variables could be, for example, access to finance or access to education. Those are known as independent variables. So any changes in the independent variables will affect the dependent variable. We analyze data to see if we can find patterns or relationships or trends in that data. And there are two specific types of data, namely quantitative data and qualitative data. Your quantitative data is literally numbers. But qualitative data can be anything relating to descriptions, quotations, opinions. When analyzing data, there are three common mathematical techniques that you can use. The first is the mean, or commonly known as the average. This is where you sum up all your data entries and you divide it by the total number of data entries that you have in your group. Right, we have a data set of 11 numbers, as you can see, and each of them have their own values. So all we want to do is sum up the set of values and we are going to get a total, and that adds up to 128, but we have 11 numbers in our set. So we take that there and we are going to divide the total that we've added by the 11 numbers in our set, and that will become our mean, or commonly known as average. The second mathematical technique is standard deviation. This is where we calculate how much the data varies from the mean. Let's look at a practical example of standard deviation. First of all, we have a list of numbers 1, 3, 4, 6, 9, and 19. We now know how to calculate the mean. We add up those numbers, divide it by 6, as there were a total of 6 in the list. We then get 42 divided by 6 equals 7. So our mean or average for this list of numbers is 7. We are now going to subtract the mean from each number to get a list of deviations. In other words, our first number is 1. So you take 1 minus 7, which was our mean, and you will get minus 6 as your first number in the new list that you're creating. You do the same with the next number, 3, minus 7 is minus 4, and so on. Once you've done that, you will square the resulting list of the numbers. In other words, your squares of deviation is now minus 6 squared becomes 36. Minus 4 squared becomes 16, and so on. Once you have your squares of deviations, you will add them together and you will total 210. Now this is where it gets tricky. We've been working with a list of 6 numbers. When you take the 210, you divide it by 1 less than the number in our list. In other words, 5. So 210, which was our total of our square of deviations, divide by 5 gives you 42. You then take the square root of this number. Square root of 42 is around 6.4807, and therefore our standard deviation is 6.48. The third mathematical technique is known as trend lines. This is where we can potentially predict the future. We take data and we plot it on a graph, which is known as a scatter graph. We look at where the points lie on the graph and we draw a straight line to indicate the trend. Let's take a look at a practical example of trend lines. The data we have gathered is at a public swimming pool over 8 days with varied temperatures. So what we want to plot is the number of people that attended on the different days and see what the trend was. So our ultimate goal is to predict how many people will attend the swimming pool at a given temperature. Let's have some fun. Let's take the following example. We have a public swimming pool and we collect over 8 days how many students come to the swimming pool on varied temperature days. Let's have a look and we're going to plot our graph online now. So we are looking now at our trend lines, also known as lines of best fit example. We have 8 days, and on those days we recorded the temperature as follows. On day 1 we had a 20-degree day, day 3 36 degrees, and etc. until we got to our last day on day 8, 26 degrees. We are now going to collate the number of people that came and visited the pool on those days, and here is the data for that. Alright, so we're now going to enter the data that we've collected. So on day 1 at 20 degrees Celsius, the number of people that visited the pool were 280. So as you can see on our graph, there is our point for the 280 people that visited at 20 degrees. On day 2, 360 people visited because it was a hotter day. And there is our mark there now. On day 3, it was 36 degrees. We had 450 visitors. There we go. There's our third point on our scatter graph being plotted. Right, we're near the end of our data list. And on day 8, it was a bit of a cooler day again at 26 degrees, and only 320 visited the pool. So as you can see, we have 8 scattered dots on our graph. We're now going to look and see what is the trend of this data. We need to draw a line between the data points here. So as you can see, it's quite tricky to draw your trend line, but you just find the line that best fits amongst the data. 4 points above and 4 points below was good enough to draw your trend line. So the trend line can also help us to predict what could possibly come next. For example, if our day 9 temperature was 40 degrees, we could possibly now predict, because of the trend line that we've drawn, how many visitors would come to the swimming pool that day. So the temperature is 40 degrees. We draw our line from there to our trend line that we drew. There's our line, and then from here we are now going to go towards the y-axis to predict how many visitors we have. So here we have our line, and we can sort of predict that 550 visitors will have come to the pool on a 40-degree day. So to summarize, a trend line can be very useful to assist us in predicting what could happen in the future. After analyzing your data, you will need to report on that data. The easiest way is to make use of graphs, as it is much easier to view and understand the data collected. There are various types of graphs. For example, tables. Tables are used usually for exact amounts of data and to display numerical information. However, there are some limitations to tables in that it is difficult to examine overall trends. Line graphs, on the other hand, are used to display data or information that continuously change over time. Bar graphs are used to compare facts, but they can have a limitation in that it is difficult to read accurately, and visual perception may play a role in inaccuracy of data. Circle graphs are used to compare the parts of a whole. However, this leaves a lot of room for human error. Thank you for joining us today on Unit Standard 252036. My name is Monique Ward, and I look forward to seeing you next time.